Good evening, all of you. Welcome, you guys. How you are doing, all of you? Very good evening to all of you. I hope all of you are doing great. Welcome you all. So first of all of you do like the sessions, everybody. So welcome you guys. Welcome to Unacademy, India's largest online education platform. India's largest online education platform. So as you might know, with this Unacademy special classes, we have so many benefits you can see. Special classes benefits you can see. So with this, you can plan. So here this interactive live sessions and polls, raise a hand options, never miss a classes, lecture notes, and anytime, anywhere you can access the classes. And so Unacademy is conducting the daily scholarship test also. Unacademy is doing the daily scholarship test also. So there is a great opportunity to all of you. All of you, first of all, join the session. All of you share the session to all your friends. Next, the features of Unacademy community features. With this, so this you can join the community regular updates from the educators. So instant class notes and DPP exam tips and tricks आपको मिलने वाला. Preparation stocks. You can join this Unacademy educator community. So these are the new batches we are starting the course which is in the bilingual both English and Hindi में चलेगा एक course and you can see the target 2023 batch and I'm going to start the digital electronics at 3:45 p.m. from the 29th June onwards. And these are the top educators of India you can see here and this Vision 2024 batch this is also GATE 24th onwards, June 29th onwards, we are starting. And these are the top educators you can find. And ESE 2023, June 29. Bilingual, so electrical. So these are the top educators you can find. So I'm going to start the digital electronics from the 29th onwards. You can take the Unacademy subscription without any additional fee. Without any additional fee, you can avail the Unacademy subscription. So without any additional EMI cost. And you can plan for this one-to-one mentorships by using the iconic subscriptions. You can practice all the GATE and ESE practice questions with the Unacademy PYQ series. These are the GATE 2022 top rankers from Unacademy. And these are the ESE 2021 top rankers from Unacademy. And you can see this. So with this Unacademy plus features, what we have is you can plan it as a with the plus, you can do it as a you can plan for this as a top indicators and you can see and the doubt solving and study notes test series. These are the features of plus. In addition to that, with the iconics, you will get additional benefits of. In addition to this, you will get physical notes milega and one-to-one live mentorships and so you will get the study and study program as well as the live interaction with the educators. Yes, first of all, yes, check now whether this audio video is clear or not. You can take the Unacademy subscription by using a code of BV Reddy. By using a code of BV Reddy, you will get additionally 10% discount आपको मिलने वाला. चलिए हम शुरू करेगा. Tell me all of you. Let's start our discussions. How many problems we have finished in the previous class? How many problems we have completed in the previous classes? You tell me. How many problems we have finished in the previous classes? 48 we have finished it, right? Next take the 49th one. Take the next problem, all of you. Take the next problem, 49. In the network shown, the switch is opened at t equal to 0. Switch is open t is equal to 0. Prior to that, the network was in steady state. The network is in steady state. Before switch is open, the network is in steady state. They ask him to find the Vs of t at t is equal to 0 is. Now, so they ask him to find the Vs of 0 in the sense what we can say this is 0 plus. What the value they ask to now, transient state value or steady state value? They ask him to find the transient state value. Transient state values will depends upon the past behavior. Transient state values will depends upon what? Past behavior. Is the font size is okay? Tell me first of all. Is the font size is okay? Right. Now tell me now here. So transient values will depends upon the past behavior. So now tell me now at t equal to 0 minus, can you analyze and circuit at t is equal to 0 minus? T is equal to 0 minus, which is opened at t is equal to 0. T is equal to 0 minus, which is closed. Then how we have a connection, you tell me? So here in steady state, so capacitor which is closed here. Now here this inductor is shorted. Here which is equal to 10. Now here is capacitor. So there is never flow of current through this capacitor, isn't it? So why? Because we have shorted path is there now. Parallel to that we have shorted path is there. Then there is no flow of current through the resistor and capacitive part, isn't it? So that means how much this current I can say this is IL of 0 minus. And so this voltage which we can say this as VC of 0 minus. Can you tell me here how much this IL of 0 minus, which is equal to what we can say the complete current will flow in this path only. There is no flow of current in this direction. So this current is completely 0. So what I will get, you tell me now here, which is equal to 1 amp, and the VC of 0 minus, which is equal to 0 volts. All of you tell me. Next. Now these are the initial values. Now let us talk about the t is equal to 0 plus values. Now at t equal to 0 plus, t is equal to 0 plus, what happens you tell me? Which is called as a transient state. In transient state, how the inductor will behave as what you tell me? Inductor which will behave as a open circuit, capacitor will behave as a short circuit. Now tell me at t is equal to 0 plus scenario, what happened to switch, you tell me? What happened to switch now here? Switch is closed now. Switch is opened. Switch is open, capacitor is short circuited with the initial value. The initial value of a capacitor which is equal to 0. Then I can say voltage 0 means we can say make it as short circuit. Now this inductor which is open circuit with the initial current. right? How much is initial current of inductor, you tell me, which is given as 1 amp. So here this is 10 ohm resistor, and so this is 10 volts. Now you tell me now here, so I need this voltage, right? This voltage, which we can call this as Vs of 0 plus. This thing we want, right? Now this current, which is equal to 1 amp. So then this voltage, which is equal to 10 volts, and this current, which is also equal to 1 amp. So that means this voltage, which is equal to 5 volts. Now we can write a KVL in this loop to get this Vs of 0 plus. Tell me, by writing the KVL in this loop, what we can say here. So which is equal to 10, which is equal to 5 plus 10 plus Vs of 0 plus. So how much this value? So this is Vs of 0 plus, which is equal to minus 5 volts. Take it all of you. Done. Is audio video is clear to all of you? Fine. Chalo, next problem. And take the next problem. Find Vc of 0 plus when the switch is closed at t is equal to 0. Now what they're saying is at t is equal to 0, switch has been closed. Now let's talk about the t is equal to 0 minus scenario. T is equal to 0 minus. At t is equal to 0 minus, switch is open. When the switch is open, supply connection is there for my capacitor. So what we can say, my capacitor will reach us to steady state. So in steady state, my capacitor, we have only capacitor only now. My capacitor will behave as what, you tell me? The capacitor will behave as a open circuit. Now draw the circuit now at t is equal to 0 minus, which is opened. Then which is opened. Font size is okay now, so I think font size is fine. Here is my capacitor which is open circuited. So I'm calling this as Vc of 0 minus is 5 volts, and here this is 1, and this is given as 1 by 2 ohms. And here is we have a switch connection, but the supply, this switch is open, then there is no flow of current here. The switch is open here, then there is no use of this part. So can you find the Vc of 0 minus, you tell me? By writing the VDR, we can say this is Vc of 0 minus, which is given as 1 by 2 by 1 plus 1 by 2 into 5. So tell me here how much it is, 1 by 2 by 3 by 2 into 5, which will get this as 5 by 3 volts. That means Vc of 0 minus, which we got it as a 5 by 3. So tell me now, all of you got the same values or not? 5 by 3. So that is at t is equal to 0 minus. Now let's find the t is equal to 0 plus values. T is equal to 0 plus. At t is equal to 0 plus, what happened you tell me? The switch is closed. Switch is closed, and which is a transient state. And the transient state. In transient state, the capacitor will behave as what you tell me now here? Short circuit with the initial voltage source. And now redraw the circuit. Now redraw the circuit. The switch is closed now here. Here in this case, switch is closed. This is 5 volts and this is 1, and here which is 1 by 2 ohms. Now this is 2 ohms, and this voltage which is equal to 5 by 3 volts. Yeah, now you tell me now here. So this is my ground now here. So that means this voltage which we can say 5 volts, and this voltage which is equal to 0 volts, and this voltage which is equal to 5 by 3. Right. I need this current is required. Now if I call this current is something here, I1 if I say, can I get this I1 value, and this current is I2 I am calling. So tell me now here I1 value which is equal to 5 minus 5 by 3 by 1. So how much this value tell me? Which is equal to 5 minus 5 by 3 by 1. So we'll get, if we take the LCM 5 minus 5 by 3 now here, that is 15 minus 5. So that is 10 by 3. 10 by 3. Now if I call this current is I2, what about this I2 is a 5 by 3 minus 0 by 1 by 2, which is equal to 10 by 3. Check it all of you. And this is 10 by 3. Now you tell me now here 10 by 3. Here 10 by 3 current is entering, and 10 by 3 current is this current. How much this current you tell me? 10 by 3 is entering and 10 by 3 is leaving. So then what about this current here in this path current? What about in this path current you tell me here? So this path current which will become 0 now. This current which will become 0. So from this what we can say now here? So that is IC of 0 plus. How much this value? 0. Check it all of you. Next. And take the next problem. The voltage across a resistor R at t is equal to 0 and at t is equal to 1 second is the voltage across this resistor. So here t is equal to 0, switch has been closed. T is equal to 0, switch was closed. So what we can do, tell me? I can get the voltage across the capacitor we can find now. So we can say VC of 0 minus, which is equal to 0, and VC of infinite, which is equal to how much now here? 100 hoga na. Then tau, whatever tau is equal to RC, so which is equal to 2 into 10 power 6 mega, that is 1 by 2 into 10 power minus 6. So that is how much the tau value, which is equal to 1 second. Right, so from this we can write my VC of t, which is equal to final value plus initial minus final. So it is 100 into e power minus t. So this is the expression for my, what is this thing? This is the expression for what you tell me? Voltage across capacitor. From this, can I get the current through the capacitor? I equal to C into dV by dt na? dVc by dt. So from this, by differentiating the current voltage with respect to time, we'll get the current now. C value given us, what we can say here, that is 0.5 into 10 power minus 6. Okay, derivative. So what we'll get here, which is equal to, this is 100 into e power minus t. So how much will get the current value? Tell me. Current value, which we can say this as 50 into e power minus t microamps. Tell me now here, this is my IC of t. This is my IC of t. We got like this. Now whatever the current is flowing through capacitor, the same current will passes through the resistor also now here. So from this I can get the voltage now here VR of t, which is equal to what we can say here 2 mega. So means what we'll get now here. So 2, that is 100 into e power minus t. Check it here. This is my voltage. Now at t is equal to 0 and t is equal to 1 second, we need the voltages. What is a VR of 0, which is equal to 100, and VR of infinity. So 1 second. How much it is? 100 into e power minus 1. How much is value? I think so. E power minus 1 means nearly 37. So I think so 36 point something. Yeah. So this is 36.8 volts will get. So option C, check it all of you. Done. Next. In the circuit shown in the figure, the switch is closed at t equal to 0. Switch is closed at t equal to 0 with the capacitor uncharged. That means initial value of capacitor is given as a 0. Fine. Now the value of di by dt at t is equal to 0 plus. So initial value Vc of 0 minus, which is equal to 0. Yes, initial value to 0 I. Now at t is equal to 0, switch has been closed. Yes. So can you tell me now here what is this thing I of 0 minus value? What is the current passing here at t is equal to 0 minus? So there is no supply at all. Switch is closed at t is equal to 0 only. So this value 0. Next. So now at t is equal to 0 plus. At t is equal to 0 plus, what happens now? Which is a transient state now? In transient state, capacitor will behave as what you tell me? Short circuit. Transient state capacitor will behave like a short circuit. So from this, can you get the value of I of 0 plus, which is equal to 100 by 1k 10 cube? Yes. How much this value? Tell me here. That is 0.1. Check it. This current is 0.1. That is I of 0 plus. Now if I write the KVL to this loop, if we write the KVL in this loop, now tell me what I will get here. At t is equal to 0 plus, we are writing KVL. 100 is equal to what I can say here. So here that is 10 cube into I of t. Okay, plus what is the voltage across capacitor, which is equal to 1 by C, that is 10 power minus 6 integral of what we can say here, integral what now here 0 to t of I into dt. As we know, initial value of current is 0 na. voltage 0, current 0. Now if I differentiate both sides, so it will become 0 equal to what we can say here, 10 cube into di by dt plus what we can say 1 by 10 power minus 6 into I of t will come now. Check it. Now, if I consider a t is equal to 0 plus conditions, so that means what we'll get now here, 10 cube into, that is di of 0 plus by dt plus 1 by 10 power minus 6 into I of 0 plus, which is equal to 0. Check it. Now I of 0 plus, which is equal to 0.1. So from this, 10 cube into di of 0 plus by dt, which is equal to 10 power 7 into what we'll get now, this is 0.1 into 0.1. So this is finally what we will get now, di of 0 plus by dt minus, which is equal to what we will get now here, 10 power minus how much we have left out here, 10 cube. Check it. 10 cube, isn't it? Hmm? How much it is? 10 power, so this is 3. Yes. So 10 cube, isn't it? So option D now, check it all of you. 10 cube or 10 square? Hmm? Yeah, this is 6 only, na? So now tell me how much you'll get here. 10 square. Check it. This is 6 only now. When you take to up now here, this value 0.1. Check it. Isn't it? Which is equal to minus 100 amperes per second. Isn't it? So option B. Check it all of you. Next. Hello, next problem. The differential equation for the current I of t in the circuit is. Now, I hope you can do this problem. Try it. The differential equation they ask him to find. So simply we can write the KVL in the loop, you can get it. Isn't it? Simply write the KVL in this loop. This current is I of t. Simply write the KVL. I can say now here sin t. Sin t, which is equal to 2 into I of t plus L into di by dt. L into di by dt plus 1 by c into integral of I of t into dt. Now if I differentiate both sides, so which will becomes cos t, which is equal to 2 into di by dt plus 2 into d square I by dt square plus I of t. Now check this option क्या होगा? So finally 2 into d square I by dt square plus 2 into di by dt plus I of t, which is equal to cos t. ऑप्शन सी। ये तो बच्चा प्रॉब्लम ना। चलो नेक्स्ट प्रॉब्लम। Now you try this thing. The the, for the circle shown the switch is in position 1 for a long time. This is position 1 and this is position 2. And it is thrown to position 2 at t is equal to 0. At t is equal to 0 plus the current I1 is. Now tell me. Initially switch is at position 1. Initially switch is at position 1. The switch is moved from position 1 to position 2 at t is equal to 0 plus. Now, fine. So tell me now here, at t is equal to 0 minus, which is at position 1 and the network is in steady state. Right. Now draw this network at t is equal to 0 minus, which is at position 1. So, so the capacitor will behave like open circuit and inductors are short circuited. Right. Now this voltage, and which we can call this as VC1 of 0 minus. This is V. This is R. So if you see carefully now here, what is this VC1 of 0 minus is equal to V. And there is no current at all. So this is open path now here. What is this thing here? This is IL of 0 minus. IL of 0 minus is 0. And what about this is VC2 of 0 minus? VC2 of 0 minus, which is equal to 0. Right. Now, let's focus about a t is equal to 0 plus. T equal to 0 plus. Now, at t is equal to 0 plus, what's going to happen? T is equal to 0 plus. So, which is a transient state? In transient state, so the switch is moved to position 2, right? And transient state capacitor will behave like what you tell me now here? Short circuit with the initial voltage. How much is voltage of this capacitor here? This is positive and negative. This value is a V. And what of the inductor? Inductor will behave like open circuit with the initial current. But there is no initial current now, so it is 0. And capacitor, second capacitor will behave like a short circuit with the initial voltage. But VC2 which is 0. So that's why this is also short circuited. Now this is R and this is R. Now they given this current, this loop current is given I1. If you see carefully, in the two loops, only one current will flow now. This current is I1 of 0 plus, I can say, tell me. Both the loops, same current will flow, isn't it? This is the current, but here this is the current directions. So what we can say now here, I1 of 0 plus, which is nothing but minus V by 2R. So option A. Check it all of you. Done. Next, the switch is closed at t equal to 0. Find I of 0 plus. Find I of 0 plus. The switch is closed at t equal to 0. Find I of 0 plus. They given the initial currents of the two inductors has been given, right? Yeah, the two inductors has given like this, and the switch is closed. Two H, and this is the 2H, and these two inductors have some initial currents given, and the initial current of this inductor will conduct parallel current. The initial current is parallelly, so this current which is given as 2 amps, whereas the another inductor having the current this direction, opposite direction, initial currents are this is 1 amp. Which one you're talking about? This problem, right? Now they ask him to find the current. So what we can do, the two inductors are ideal inductors, they has connected. So let us go for the Laplace domain, S domain. Let us do the Laplace domain. If I converted Laplace domain, so which is equal to 2 by S, and this is 2S, and this is 2S, and this is 1 by S. Now we can apply the Laplace domain converted, and we can apply the source transformation here. If I write the source transformation, tell me what I will get. These current sources are converted to a voltage sources, and this is positive and negative, and which is equal to 2S, and this value which is equal to 4. Next, the another inductor which is 2S, and this value, and given as this is positive, this is negative, and which is given as what we can say now 2 volts, isn't it? Now let's find the current. So this current. Now this current is now I of S. Can you tell me the I of S here? I of S now here. 4 minus 2, isn't it? That is 4 minus 2 by 4S, which will get it as 2 by 4S. And means what we can say, this is 1 by 2S. This is my I of S, which is a Laplace domain, which we have this as 1 by 2 into 1 by S. If we convert into inverse Laplace, I of t, which is given as 1 by t, 1 by s, which is equal to constant now here, simply 1. This is my I of t. So how much is I of t value here, which is equal to 1 by 2. The current which is always, it is a constant, you see, 1 by 2. So even though they ask him to find the current at t is equal to 0 plus, here also which is 1 by 2 only now. This is also 1 by 2 only. Done? Yes. Fine. Next. Next problem, tell me. What is I of t when the source is del of t? When the source is given as del of t, they ask him to find I of t. Now, so if we see carefully now here, this voltage which is equal del of t parallel now here, and here also voltage is del of t only. Now if we write the KCL at this node, We write the KCL now. Tell me what we'll get now here. This is I, which is given as IC plus IR, sum of the two currents. IC plus IR. Tell me now here. So this is IC. IC, which is given as C into what we can say dV by dt. So the voltage which is given as del of T na, plus IR, which is given as del of T by R. So finally I is equal to, so derivative of del of T, which will get C into, we can say here, del of T is an impulse signal. Del of T is an impulse signal. Impulse. So the derivative of this impulse signal is called as a doublet signal. Doublet is called as a doublet. So this is the derivative of d by dt of del of t. This is called as a doublet signal, which is indicated as del dash of t. Where this del dash of t, which is called as a doublet signal. Impulse signal, derivative of impulse signal is called as a doublet. Okay, so that means what we can say, so doublet, so that is the derivative of impulse is a doublet, and you will get to know more clarity about the doublet signal in the signals and systems, and when you are discuss signals you will get to know more clarity about the doublet. So derivative which is equal to doublet signal del dash of t plus what we can say now here, that is 1 by r into del of t. So this is the expressions. So what's the option you tell me? Option B. Okay. So the doublet signal, which is defined as derivative of impulse signal, is defined as a doublet signal. Derivative of impulse signal is called as a doublet signal. Okay. We are doing the signals. We are going to start from the 13th July onwards now. So here, so we'll do. So and so once we started the signals and continuously we'll do that one, and so daily regularly we'll practice the sessions, and daily we'll practice the sessions, problem session, either special class or YouTube classes, continuously will run. So and for signals I'm doing this thing here, I'm trying to prepare the short notes, everything and all now only. So you will get the short notes and DPP, you will get it. Starting class only I will try to provide the short notes, DPP, etc. The best possible manner and preparing the notes, so that you fellows will enjoy the notes. Like you might see the digital notes you have seen now, digital notes, digital short notes you have seen now. The same manner I will try to provide digital short notes, math short notes, and EMT short notes. The similar manner I will try to provide. Yes, and see this problem. Now try this problem. I think so. This problem you can easily solve it. Try this thing. Hmm? Done this one? Tell me. Stated. So the network is in steady state, right? The network is in steady state. In steady state, the inductor and capacitors. Inductor will behave like a short circuit, now tell me. And capacitor will behave like an open circuit. Isn't it? Under steady state. So what happened in the scenario? Redraw the circuit now here, then you will get clarity now here. Under steady state, here this capacitor which is open circuited, inductor is short circuited. No, no, don't do nodal. So don't do nodal. So here, if you do the so easily, so simply VDR से हो जाएगा. Simply we can do VDR. No need of nodal. Nodal करने की जरूरत भी नहीं है. ये तो बच्चे problem. So this inductor is shorted, and here we have a resistor. And here this capacitor which is open circuited like this. And here this is 40K. Now you can tell me. And this voltage which is equal to VC1. And this voltage which is given as VC2. And this voltage which is equal to VC3. Now you tell me now here there is no flow of current here, isn't it? This current is 0. That means voltage across this 40K is nothing but I can say VC1, VC1 I can say. So how much the VC1 you tell me? So by using VDR 40 by 50 into 100. So which is equal to what we can say here? This is equal to 80 volts now. That means this voltage is 80 volts. That 80 volts will be divided for these two capacitors, C2 and C3, isn't it? So, and if I redraw this part separately, here we have two capacitors we have, and of course there is no flow of current, there is no voltage across a resistor. Simply I can remove the resistor also. Right, this is the scenario. We applied this combination of these two capacitors are 80 volts. Now this capacitance which is given as a 2 farads and this capacitance is given as a 3 farads. Right. And this is my VC2 and this is VC3. Now let us apply the VDR again. Capacitor case VDR, as we know, Q is equal to C into V. Q is equal to C into V. So that means what we can say, series connection of these two capacitors, Q is a constant. Q is constant. So what we can say, voltage proportional to 1 by C. Right. So what we can say now here, VC2 means we should take the opposite capacitor, we should take, that is 3 by 2 plus 3 into 80. So that is, which is given as, how much you tell me now here, 3 by 5 into 80. How much you will get this value, which is equal to 48 now. Next, VC3. VC3 and which is equal to what we can say now, 2 by 5 into 80. So how much this value, which is equal to 32 volts. So कौन सा option now here? 80, 48, 32. 80, 48, 32. Option B. Next. And see this problem. Assume initial conditions are 0. Assume initial conditions are 0. They given this, we need to match these circuits to corresponding this thing here. Look at now here. Let us find out the expression here. They given the current expressions. Current, they are saying. Let us find the current in all the cases. First case, you see this thing at t is equal to 0, switch is closed. So let's find the currents in this case now. Tell me. And what we can say now here, IL of 0 minus, which is equal to 0. And IL of 0 plus, which is equal to what we can say, V by R. So that means what we can say now here, IL of t, which is equal to what we can say now here, V by R into, that is e power minus t by tau now. Now tell me now how this variation, you tell me. So this is how this variation, you tell me, if you draw this graph, then what happens, you tell me. So now when t is equal to 0, then how this is, now tell me. This value, when t is equal to 0, this value 0. So that means slowly increases now here. Slowly increases. So this means current increases monotonically with time, isn't it? That means for A, which is 1, for A, which is 1, for A, this is 1, isn't it? Now you tell me this option, you tell me here. Second case, now here this current expression you find out. So we'll find the VC of 0 minus, which is equal to 0, which is also equal to VC of 0 plus. Next, VC of infinity, which is equal to V. So that means VC of t, which is given as what we can say here, V into V minus e power minus t by tau. Okay, that we need the current we need now. So this is I is equal to C into dV by dt. So what I will get, you tell me. Okay, C into dV by dt. So what happens, you tell me. Now here this is Cv into by tau into e power minus t by tau. Then can you tell me how this variation of this function? It is exponentially decreasing function. So for this thing, so the 2 is option, now tell me. Now if you see carefully here, Here you tell me now here. So this is resistor, inductor, capacitors, all these three are connected in series. Now you tell me now here. So at t is equal to 0, at t is equal to 0, what happens you tell me? At t is equal to 0. So here the transient state. In transient state, what happens now here? In transient state, if we say, in transient state, inductor is what you tell me now here? Inductor, it will behave like a open circuit. Capacitor will behave like a short circuit. Isn't it? Then what is the current here? Current. So that is I is equal to 0. I of 0 which is equal to 0. Now tell me now here. So now here tell me now what happens, you tell me now here. So here and at t is equal to, so here well inductor is short circuited and capacitor is open circuited. Yes or no, tell me. It is a vice versa, isn't it? All of you. Then as a result what happens, you tell me now here. कौन सा option होगा? So you see, will the current remains constant as V by R? It won't be now here. It won't be. Next, what else you tell me now here? Will the current decreases first and then increases? Isn't it? How the scenario? Will it be the options, possible option? Now you see this current now here. I of t, which we can say that is V by what we can say now R plus. Okay, so J omega L minus 1 by omega C. This is the scenario, tell me now here. This is the current. Second circuit means this thing now. How we get denominator? So we no need of denominator. Now we need what now? How the variation is required. So here they given increasing, decreasing. Just we need the variations only. Yes or no? No need of denominator etc. here now. So we just see the variations now here. How this function now here? Tell me. Treat this whole thing as some constant. Treat the whole thing as some constant. So that means like we can say IC of t, simply treat this as something k into e power minus t by tau. How the function variation now here? At t is equal to 0, this value maximum. As the t value increases, this value decreases now. So that's why just the observation we can say no need of the value. So they're not asking the value now. So here to get the value, tau value, we need to replace. Now let's talk about this next one here. In this case, you tell me in this circuit now here, will there any flow of current, you tell me, in the network? At t is equal to, so here, so this initial values are completely 0. The current is given as what we can say here. This is the expression now, tell me. And what is the supply here? What is supply here? Which is equal to DC supply. What is supply here? Which is equal to DC supply. Now tell me, will there any flow of current here? In DC supply, so that means current. So what we can say I of t, which is equal to V by that is R plus J into this value. So this inductance value which is equal to 0, but capacitance value which will become infinite or not? Omega. Isn't it? Okay. So from this, what we can say, do we have any flow of current in the network? You tell me. Do we have any flow of current in this network? There won't be any flow of current in the network. There is no flow of current in the network. So for this option 5 now tell me. Hmm? All of you. See the network here. The switch is closed at t equal to 0. Switch is closed at t is equal to 0. We have a resistor and inductor is there and capacitor. So this is R, L, C. This is V. Okay. Now you tell me now here at t is equal to 0. What happens? You tell me now here there is no initial values. Completely initial values are completely 0. Now tell me now here when this is short circuited. When this is short circuit, this will become open circuit now. Then what is the current in the network? You tell me, which is equal to 0. The current in the network which is equal to 0, isn't it? Okay. So what's the option? You tell me now here. 1, 2, 5. 1, 2, 5. That means option C. Fine. Right. Okay. Yeah, that's for the today's session, and we'll meet in the next class. The next class, I think, sir, the next class, next YouTube class on 28th, we have one more YouTube session we have. Okay. Yeah, that's for the today's session, and we'll meet in the next session. Okay, then. See you. Bye bye. Take care.